So as I have said, there are a number of things. Regions on a plane have been removed from the course. All the things I've talked about that have ticks are still part of the course. So the important thing to remember though is z is equal to x plus yi. Okay, and I'd like you to write that for the time being. Do you have to write that in an exam? No. What you should instantly go to is we're given this rule x plus yi minus I is equal to 1. Okay, so that's where we start. Now, from there, what we need to do is let's group our terms, and let's do this. X plus, let's take I out as a factor there. We've got y minus 1, like so. Now, what is this? These two vertical lines? That is the modulus. So, in other words, we're using Pythag to state that these two lines are equivalent. And of course, we're looking at the square of each component. The square of the real component is so x squared plus y minus 1 squared is equal to 1. Okay, so now what we can do, if I want to sort of solve that and have a Cartesian equation, let's square both sides. So therefore we've got x squared plus y minus 1 all squared is equal to 1. Write this rule in Cartesian form. I guess this would be sort of considered 1 mark, and having the right Cartesian form be 1 mark. So what do we have? This rule refers to a circle. You don't need to do this, but it's a circle. Just to picture it, centre 0, 1, and it has a radius of 1, doesn't it? A radius of 1. And we might be asked to sketch that region. We can do that, but it's not a region though, it's really just a circle on an arcane diagram. So it says here, find the points of intersection of the graphs with the rules this and this in Cartesian form. The points of intersection. Okay, so I have that as 1. What about the other one? Can I get you... Now remember that we have a CAS calculator, but there has to be some method mark associated with this. So we've already done this one. Let's have a go at this one. So therefore we can say that z minus 1 is equal to 1 is... that is equivalent to x plus yi minus 1 is equal to 1. Which I can go straight to, if you like. I can go straight to this. X minus 1 squared plus y squared is equal to 1. And squaring both sides, I can say that x minus 1 all squared plus y squared is equal to 1. Okay, that's probably my method marker, but it says find the intersection of the graphs. There's some method mark there. We can do that in the calculator, however. So what I want to say is where they intersect, there's one equation. The other one is x squared plus y minus 1 all squared is equal to 1. What I could do is I could do this. They're both equaling 1. So where do they intersect? Well, I would just go ahead and use my CAS because it's an exam 2 question. I could, if you like, I could solve a set of equations. Menu, algebra, solve system of equations, solve system of equations. Yep, we've got x and y, like so, and I can put that in. So we've got x squared plus, what was it? Was it y minus 1 all squared? And that is equaling 1. And the other one was correct me if I'm wrong, was it x minus 1 all squared?
Yeah.
X minus 1 all squared. Was it plus y squared?
Yeah.
Plus y squared. And that is equal to 1 as well. There we go. X equals 0 and y equals 0, or x equals 1 and y equals 1. So we do that in our calculator. You probably find, however, so I've done a little bit of working, maybe there's a method mark involved. You probably find that what would be suffice is if we said Cas they intersect at, was it 0, 0 and 1, 1? And 1, 1. Okay. Now, hope you're following me so far. Now let's have a look, and it says shade and label the graphs with the rules z minus 1. Now just note, whenever I have something in this form, it's always going to be a circle. So what do I have? I have a circle which is centred at I and has a radius of 1. So in other words, there you go. Let's just try and map that out. It's going to go across here, it's going to go up here. So I've got a circle which is going to look a bit like so. Okay, there's my first circle. So that is a sketch on the Argand diagram of that. The second one has a centre at 1, 0. So I'm going to mark a little dot there, and I'm going to mark that up there like so. And they're the 4 corners of my circle. Well, you don't really have a corner of a circle, do you? And as you note, look, this is where they intersect. We just found that in the previous part, didn't we? 0, 0, and there's an intersection there at 1, 1. Not that you need to put that on your... Don't go putting that on your graph. You're not asked to. You've just been asked to sketch and label those graphs. Okay, so this one here is z minus 1 is equal to 1. So essentially you're just drawing 2 circles. Be careful though, if you draw your circle out of whack, you'll lose your mark. If it's not quite obvious that they intersect at 0 and 1, 0, 0 and 1, 1, then you might lose a mark there. Okay. Now, find the equation of the straight line which passes through the points of intersection. Find the equation of the straight line which passes through the points of intersection. What do you think that will be? I've got intersection points at 0, 0 and 1, 1. What's the y-intercept? 0. What's the gradient? So therefore the line is what? Is y equals x. Quite pretty straightforward, isn't it? Now, the straight line found in that can be expressed in the form z is equal to alpha z bar. Find the value of a, or alpha. What would that be? I might get you to have a think about that. Let me do that for you. So, z is equal to x plus yi. Z bar is equal to x minus yi. That's where I would start. Now, if z is equal to alpha z bar, therefore, guys, I'm recording this, so it's going to be pretty loud otherwise. X plus yi is equal to alpha x minus yi. Oh, I haven't. Okay. That's better, yeah?
Yep.
Okay. Now, however, so we've been given that. However, we can say where do they intersect? They intersect at 2 points. One's not going to be too helpful, but they intersect at, there's an intersection at 1, 1. So let's throw that in. So therefore we've got 1 plus I is equal to alpha 1 minus I. Okay. Now, we can say, if those two statements are equal, what can you tell me about alpha? Alpha must be I. Yeah, it's definitely... Now, a lot of people would go, oh, alpha's 1. No, it's not. But... Now, we could do it one of two ways. We could just instantly say, go from there to saying, therefore, alpha equals I. Or, we could do this, couldn't we? We could say that alpha is equal to 1 plus I over 1 minus I, and I multiply by the conjugate, which is 1 plus I over 1 plus I. And on the top, that's going to give us 1 times 1 is 1, plus 2i minus I squared, or sorry, plus I squared, which is minus 1. In the bottom, we're going to get 1 plus 1, which is 2. Look at that. 2i over 2, which is equal to I. But of course, we would have saved yourself some time if you had a bit of a think about it. And have a look. It says, where alpha is an element of the complex plane. So, I would be underlining that if I was doing that question. Okay, let's push on. And this time, we won't do regions because we don't need to anymore. Let's have a go at this one. Okay. Now, given your knowledge that z is equal to x plus yi, and the modulus of z is equal to the square root of x squared plus y squared, or the real part and the imaginary part squared, can I please get you to have a go at these? I'm going to pause this now. There's a little bit of work involved in this, and I'm recording now. I guess what we could say, if you like, we could break it down. We could say that the left-hand side, we could do the left-hand side and equate it to the right-hand side. So at 0, 0, z is equal to 0. And therefore we can say that the left-hand side is negative 1, the magnitude of negative 1, which is equal to 1. Okay, so we've dealt with the left-hand side now. Let's have a look at the right-hand side. At 0, 0. At 0, 0, what do we have? We have z is equal to 0. So therefore we've got z minus a half minus root 3 on 2i is equal to the magnitude of negative a half all squared plus negative root 3 on 2 all squared. Now, when you're verifying, make sure that you just don't do any, just don't go that equals 1. Make sure that you show the examiners that that is 1 over 4 plus 3 over 4, which is equal to 1. Therefore, we can say we've now verified them. Yes? So, therefore, the left-hand side is equal to the right-hand side as required. Okay? It's definitely a little bit more work than you'd like for 1 mark. Now it says show that the Cartesian equation of L is given by this. So, we need to then do it the long way. Z is equal to x plus yi. which means I have x plus yi minus 1 is equal to x plus yi minus a half minus root 3 on 2i. There you go. Let's leave it like so. Now it is also a show that question, so let's not skip too many steps. What we have on the left-hand side is the square root of, let's collect those terms, x minus 1 all squared plus y squared on the left-hand side. On the right-hand side, I'll collect real and imaginary. That is x minus a half all squared plus y minus root 3 on 2. The I would be at the front, but we're just looking at the square of the imaginary component. So that's what I start with. Now let's square both sides. So we can say that x minus 1 all squared plus y squared is equal to x squared minus x. Let's leave it at that actually. X minus a half all squared plus y minus root 3 on 2 all squared. Now we have to show, so we can't just go ahead and solve and use our calculator. Alright, it's really important that you have to clearly show every step. So unfortunately, as much as we could easily do that to show in a calculator, we're not assessed on that. So we now need to expand out. So that's going to be x squared minus 2x plus 1 plus y squared is equal to x squared minus x plus a quarter plus y squared. We've got 2 minus root 3 on 2's. So that's going to be minus root 3y plus 3 on 4. Okay, now the y squareds are going to cancel out. The x squareds are going to cancel out. And let's get the y all on one side. So we've got, and let's get everything else on the other side. So we're going to do that. First of all, we've got a quarter plus 3/4 is 1. Oh, actually, isn't that going to cancel out? It is. So what we've got is we've got minus root 3y is equal to minus x. So therefore y equals x on root 3. And isn't that what we just had to show? As required. Of course, it's a bit easier for you guys to fit that all into space because you're writing with pen and writing, trying to fit that in the lines. No chance on this computer. Okay, hope you're feeling not too bad about this stuff. We might need to sketch those regions, however. And as I said, you do get some doozies in complex numbers, particularly in the past when we had some regions. All right, have a go at these ones. There's a total of, let's have a go at C and D, please. There's 4 marks there. Let's have a go at doing those. I'll pause the video. I'm just going to resume here. So with this one, first of all, I just tried to sketch out what the graph of y equals x on root 3, what it looks like. Well, if the Cartesian equation of that on an Argand diagram, we've got minus, if you like to think about it, we can say rise over run. The run is root 3 and the rise is 1, or in this case, in 1. So there you go. This would be the graph of y equals x on root 3. But if you think about it, if that's in the third quadrant, then we need to know, first of all, it says here, write down the value of alpha, and that is just the argument. What is the argument there? Wouldn't we just use SOHCAHTOA? That's theta. And therefore, I've got inverse tan of 1 on root 3, which is what? That's the reference angle, by the way. Sorry? Okay, so the reference angle is pi on 6. But what would our argument be? Is that going in... Okay, so therefore we can say that theta is equal to pi on 6. So therefore we could say that the argument of z is equal to minus 5 pi on 6. Is that right? Yeah. Yes, okay. For the second one, of course, we can use a cas, but there's method marks involved here. I'm going to say that that would be 1 mark. That would be 1 mark. And some form of method will be required as well. So in my case, I just did this by hand, but to be honest, you guys should always just do it in a calculator. All right? Because what happens if you make a mistake? Wouldn't it be a shame if you could have put it in your calculator in the first place? They haven't asked you to show anything, but I just did it by hand and of course worked it out that way. Don't even have a calculator on me. Oh, I do. It's this one. Okay. But please, use the calculator. Don't go wasting time doing that when you don't need to. Now it says sketch L and the graph of modulus of z equals 2 on the Argand diagram. Yes, we can sketch that because it's not a region. So, now you think about it. Modulus of z equals x plus yi. Square root of x squared plus y squared. So we're just looking at a circle which has a centre at the origin, and it has a radius of 2. And you guys will draw that better. There you go. There's 1 mark. It says sketch L. So be careful. We're looking at a argument of minus 5 pi on 6. So that is what pi on 6 is 30 degrees. Yeah, so that means that it would have to be this line here, wouldn't it? Would you agree? Yes. Now, in the final part, it's asking you to find the area in the first quadrant, yada, yada, yada. We're not required to do that anymore. All right, how are we going so far? Are there any questions so far? Okay, let's repeat the dose and let's have a go then at this one here. Find the intersection of the points of the curves given by this. Now, the one thing before I will let you go off and do that. Real of z is what? Real of z, what do we know that as? X. Thank you. So that's all we need to replace that with. And the imaginary of z is equal to y. If you replace real of z and imaginary z with that, you'll be able to do that. I'll pause it, give yourself a chance to do it. All right, hands up if you got that answer. 0, 0, and root 3 on 2, 3 on 2. I didn't put the what? Oh, I dropped the negative off. I didn't see. Okay. Yeah, that helps. So that's that. Shh. So what's the answers? Yeah. And that's it? Okay. Shh. So once again, shh. There you go. There's 1 mark there. There's 1 mark there. And finding your 2 equations and then putting them in your calculator. You can say that, put them in the calculator. Let's see how students have gone on some of these ones. All right, now, I'm going to stop there because class is over soon. Shh. Shh. But you'll notice a bit of a pattern, as you can see. Now, we could then sketch that, couldn't we? Shh. We could sketch that once again. And wasn't that a very similar question to the previous years? I thought it was. The next thing is, you guys will need to finish off and you need to maybe practice these ones with the ticks. Show that this Cartesian equation given by exactly the same thing, isn't it? Letting z equal x and you'll be given Z1 in the question. You can also scroll through, but just please note that anything requiring us to sketch regions and intersections of regions will not be on the exam this year. All right, I'm going to stop there.